Hi, I'm Mr. Franklin, and in this video, I'm going to walk you through our homework problem, our homework and an example of how to do a claim breakdown and evidence for your quarter project for your TED. You have just watched a video from Bozeman about claim evidence and reasoning and given you an overview. So now we're going to do that for our TED videos, but I thought it would be important that we do one together before you try to do it on your own. So first we're going to do claim evidence and reasoning for this video. So click here on this link and it should take you to the video, which is this one. And the first thing you should do is you should go ahead and watch it all the way through. So pause this video, go back to this one, watch it all the way through so you're familiar with what the video is about. So do that now. And when you come back, we will work through the process of analyzing claim evidence and reasoning. All right, welcome back. So I hope that was actually helpful in explaining some of the things we've talked about with heat and energy, as well as interesting. So first thing we're gonna do is we're gonna write the claim or essential question of the video. Now this video, that was kind of difficult to do because it's mostly informational and not like asking a question. A lot of videos will actually state their claim as the question that they're trying to answer, okay? So generally when you're writing your claim, it should be in the title somehow. This one was a little bit different, so you actually kind of had to think through it and look at it. One claim you could use is energy is hard to define, because that's kind of what the video talks about. But I decided to pick this one. This one is actually off of the TED website. Okay, if you go to the TED website, right here, the energy in the universe never increases or decreases, but it moves around a lot. Okay, and although we can't exactly see it, every time we cook dinner or shiver on a cold night, we know it's there. So energy in the universe never increases or decreases, but it does move around a lot. I think that encompasses the entirety of the video. And so that's why I wrote that down as my claim. So next thing we're gonna need to do, and I also put a link to why I chose that, because it's not explicitly stated in the video. And because your TED Talks are TED Ed videos, you can go and pull data from other sources as well. Okay, so the next thing you should do is you should take your claim and you should make sure you define the key words. This is a little easier if it's a question, but there are lots of words and we're not going to define every word, although if we were really doing a research paper on this or really analyzing it, we probably would want to, but we're just going to pick the most important. So energy is the ability to do work. The universe. What does he mean by the universe? So we may have to look that up and think about it, because another synonym for universe might be the system that you're in, okay? So we're gonna look that up in just a second. What's another key word? Never increases or decreases. So, but does move around a lot. I would probably actually do never. What does it mean to never? And then I would actually insert another row below, and then I would add another keyword. So my other keyword is going to be increase, and in parentheses, decrease. What does he mean by that? Okay, so let's go and let's look up universe. So let's type in universe. It's all of space and time and their contents. That's actually a really good definition. I like that one. It's a science definition, and I think it fits for what we're talking about. So let's paste without formatting. Physical universe is defined as all of space and time, collectively referred to as space-time and their contents. Never. What does it mean to never? That may seem silly. It's like, well, I know what never means. Okay, well, do you really? So we have to be careful. Sometimes there will be words that have common everyday usages, and then there are words that have slang uses, and then there are words that have a science use. So make sure that we are looking up the words and that we are actually understanding what we're talking about. At no time in the past or future, on no occasion, not ever. I like that because I think it encompasses the whole idea of never. So here, let's go Command Z, and I'm going to paste without formatting. So at no time in the past or future, on no occasion, not ever. I like the past and future because sometimes we say never, and then we are saying, well, okay, maybe it does in the future. So never. And then increase or decrease. Increase. See, I like this. This is helping me. Become or make greater in size, amount, intensity, or degree, which I think is important with energy to have such a full definition. Okay. Oh. Become or make greater in size, amount, intensity, or degree, because we can actually think of energy in terms of the amount of energy. When we think of light energy, we might think of the intensity, or heat, we might think of the intensity. So this is great and helpful in broadening what I'm thinking when I'm thinking about that. So now when I go back and watch the video again looking for evidence, I'm going to look for evidence that touches on these 4 key definitions. So let's work through this. As we're looking through this, I know we wrote the definitions down, but it's helpful to really watch it with the main statement in mind, the key question. Energy in the universe never increases or decreases, but it does move around a lot. That's going to help us find our evidence, because that's what the evidence should support, is that claim.
Energy is not easy to define. Things have energy, but you can't hold a bushel of energy in your hands. You can see what it does, but you can't see it directly. There are different types of energy, but the differences between them are manifested only in how they make stuff behave. We do know that the total amount of all the different types of energy in the universe is always the same.
Okay, so that's a statement of the claim right there. Total energy is the same. Okay.
And for chemists, 2 important types of energy are chemical potential energy and kinetic energy. Potential energy is energy waiting to happen. Think of a stretched rubber band. If you cut it, all that potential energy gets converted to kinetic energy. Ow! Which is
Okay, let's write that one down. That's actually a good one to write down. Okay, so we got so let's go back, and I'm actually going to turn on subtitles. I'm going to watch it in English. Okay. Think of a stretched rubber band. So that's our quote here. And that is at time 040. 040. Think of a stretched rubber band.
If you cut it, all that potential energy gets converted to...
If you cut it, all that potential energy gets converted to kinetic energy. And you feel that as pain. So that's the statement that's made at 40 seconds in. Okay, so how is this quote connected to a key word or definition or to the claim? Okay, so basically we are saying the energy of the universe never increases or decreases. So basically this is connected because one type of energy turns into another type of energy. Now, in a sense, I've restated the quote in my own words, but now I'm going to apply one of my definitions to this. So conservation of energy says that at no time in the past or future will the energy be greater or in size or amount. So the energy does not become greater or smaller in amount. It just changes its form. Okay, so basically I'm taking my idea of my definitions and applying them to my key statement. All right, so that's one. Let's go take a look at another. Let's keep watching and look for some more evidence for energy not increasing or
Kinetic
decreasing.
energy, ow, which is registered by you as pain. Like a stretched rubber band, chemical bonds also store energy. And when those bonds are broken, that potential energy gets converted to other types of energy, like heat or light.
Okay, here we are converting again. Let's start there, 051. Chemical bonds store energy, also store energy. We are quoting here, so we want to be exact here. We want to be precise.
Chemical bonds also store energy. And when those bonds are broken,
that potential energy gets converted let's see, did I write it right?
That potential energy gets converted to other types of energy, like
other types of energy. Converted to other types of energy, like heat and light. Let's see.
heat or light, or gets used to make different bonds.
Like heat or light, or gets used to make different bonds. Okay.
Bonds. Kinetic energy is
Okay. So that's a good one. How is this quote connected to a keyword or definition or claim? So basically, there is no increase or decrease in energy. There is no increase or decrease in the amount of energy. It just changes form. Okay, so I've got my quote, my evidence, and now I'm explaining how that evidence actually fits into the claim that the energy in the universe never increases or decreases. Okay? All right, so let's look for a third quote. So let's kind of think here for a second. We've got both of these talking about energy changing forms. Let's see. So we probably, but it does move around a lot. So we may want to look for something that has to do with energy moving around a lot. And I think the end of the video is where I'm going to go look for that, where the person is sitting outside. I think that would be a great place to look for a good piece of evidence. Well, let's keep watching.
Is the energy of motion. Now, molecules are always moving. They're not necessarily going somewhere, though they could be. But they are vibrating, stretching, bending, and or spinning. Take methane, which is 4 hydrogens attached to a central carbon, except that you can be still, and molecule kinetic energy.
Okay, so that's explaining thermokinetic
energy,
energy, which we haven't talked about. It's a really good explanation. You are made out of particles called atoms, which are connected in larger groups called molecules of different chemicals, which you're going to learn all about in chemistry. And all of those pieces move. Even an ice cube, which is cold, the particles in the ice cube are actually moving back and forth. They're just moving so slowly. that the ice cube registers as cold. Okay. All right, so here's where, yes. Let's see.
So when those air molecules crash into you, they transfer some of their energy to the molecules in your skin, and you feel.
I like that. That's really good because we're talking about a transfer.
And cold, by the way, are relative terms. They're always used to compare one thing to something else. So on that hot summer day, the air molecules have more kinetic energy than the molecules in your skin. So when those air molecules crash into you, they transfer some of their energy to the molecules in your skin, and you feel that as heat.
Okay, 210. Let's do this one. So the timestamp is 210. And the quote would be, the air molecules have more kinetic energy.
The air molecules have more kinetic energy than the molecules in your skin. So when those air molecules crash into you, they transfer some.
Let's see if I got that right.
Some of their energy to the molecules.
Okay, they keep it simpler. Okay. So this is specifically supporting the idea that we've got kinetic energy transferring to other kinetic energy of air molecules transferring to your skin. Make that a complete sentence. So it is the energy, the total energy is never lost or increased. It is just changed from one place to another. Okay, so I went back to my definition and ended my claim, and I pulled some of that language to help me explain why that quote is important. Okay, so I could actually keep going, especially if I'm doing a serious analysis of the video. I probably should. I really like the, as it keeps going, then we have the opposite where it's cold.
Try it at your next cookout.
We have this transfer of energy here
Too much
with
heat and you have a charred
food
mess.
heating up,
Just enough,
changing the
and you have
molecules,
dinner.
but then you eating
Once
the
in your
food.
body, the food molecules in
Okay,
your
that's a very comprehensive.
reaches your skin temperature.
Okay.
For the briefest of moments, the flow stops.
And then
And then it
here
starts up
we
again
talk
in
about
the
the sun
opposite
coming and
direction as
hitting your
energy
skin, but then
leaves
your
the
skin
warmer
actually
surface of your skin
radiating the
to
heat
return to
out
the
into the
universe
atmosphere.
around you.
That could be a valid quote. So for your actual project, you're going to want to get as many quotes as you can to do a good quality write-up. But for this exercise, we're going to take our TED videos and we're going to define up to a minimum of 3 keywords. If you've got more, then use more. You can right-click, insert a row below, and add another row, and then you can add your extra words. Find evidence. I want at least a minimum of 3 pieces of evidence. If you want to go ahead and do more than that, you are welcome to, but the minimum is 3 pieces of evidence. Okay, and you're going to do TED number 1, TED number 2, yeah, and TED number 3. So make sure you get the title, write the claim. Remember, the claim may or may not be in the title of the video. Some of those videos, it might be a little harder to determine what that video is. So you can always go to the TED Ed website and look for your video and look for some other information. Define those keywords. Just make sure your definitions have the right context for your video. and then you're going to pick your evidence. Okay? All righty. So that's all I've got. We will be talking about this some more in class. So do your best to put everything together, and then we can answer questions and discuss when we come back to our Zoom class where we will cover this. And I will cover what day we're going to do this in our weekly overview video. So that's all I've got. Thank you.